This is the second quick start video. Before studying this material, we recommend watching the previous video, link in the description. Let's move on to the plan for this video. We will create an advanced workflow in Megaladata, import and transform data, gaps detection, use the Megaladata Starter Kit for ABC and XYZ analysis, create custom derived components, call a web service, export database. We are building a workflow that analyzes products, determine prices in other currencies, export report results to an Excel file, and export the processed dataset to a database. Let's start with import. Megaladata file is our proprietary data source, offering the highest performance in import and export. The dataset with over 2 million records has been imported into the system in half a second. Let's move to the node visualizers and select data quality to assess the quality of the imported data. We are looking at data issues, one of which is that zeros in the price column are important. To address this, we use the exploration data tool. In the components list, we select imputation. Moving to the node settings. There are few zeros, we delete all records where the price is empty. Let's analyze the remaining data. Switch to the table visualizer. We focus on two fields, the field with the product price and the field with the quantity of the product sold. Now, let's return to the workflow. Next, we add a calculator node. In the calculator node, we multiply these two fields to get the total purchase amount. After preparing the data, we can move on to analytics. We apply ABC and XYZ analysis. Instead of implementing the algorithm ourselves, we use a ready-made development in the form of a derived component. Megaladata continually creates component libraries for its users, clients, and partners. To access the library, we go to GitHub account. Let's download the Megaladata Starter Kit. This library contains simple and useful components that facilitate the routine work of analysts in developing data processing scripts. Descriptions of all the components in the library can be found in our GitHub repository. We can refer to a library located anywhere in the storage, if it is the desktop edition of Megaladata. If it is a server edition, as in our case, we upload the library to the server and also refer to it. Move to the navigation panel, then to links. Add the component. The components of the imported library are available in the list of derived components. We drag and drop the ABC analysis component. It has 2 input ports and 1 output port. Let's go to the settings of the table input port. For the ABC analysis calculation, we need to mapping the field with the object and the field with the value. We run the node and look at the intermediate result. Now perform similar actions with the XYZ analysis. Add a join node. Connect by the object field, using a left join. Next, add a calculator. We connect fields to obtain the results of the ABC and XYZ analysis using the Concat function. Now, let's move to the cube visualizer and create a small report. The cube is one of the common methods of comprehensive multi-dimensional data analysis, known as online analytical processing. We add 2 dimensions to the cube and 1 calculated field. There are the sales of each product category. Let's produce a chart. This report can also be shared to other users. Now let's export the report to Excel. Select the export location, activate the node, and create Excel file. Let's set ourselves another interesting task. We need to know the price in euros for each product. It's very important that the euro price is current for each sale date. We need the exchange rate for each day the product was sold. We need to identify unique date values from the table. Let's use the grouping component. We have received 382 unique dates. Using the sort node, sort them in ascending order. This will make it easier to work with dates. Let's create a submodel that will return the current exchange rate for the first date. Call it rate by date. This submodel will access a web service that returns the exchange rate relative to the dollar for a given date. Configure the ports of the submodel. Move into the submodel. Date is required as a parameter for the GET request, so we will use the table into variables component. Using the variable calculator, we assemble a string for the GET request. We will be accessing the conditionally free web service openexchangerrates.org, link to this web service in the description. To find out the exchange rate, we need to assemble the necessary string for the GET request. First, we need to add a token for access in the input port of variables. Create a field with the text of the GET request. Now, we need to create a new connection. It is used for interacting with databases, ODBC drivers, web services and other integrations. Go to the navigation bar to the Connections section. Add REST service. Since we will be substituting the connection string from the one assembled in the calculator, the URL can be formal. In our case, the GET method is required. Go to the Connections section and add a connection node on Workflow. If we simply drag the connection to the workflow, we will not be able to substitute the assembled link into the connection. In the REST service settings, we specify that the URL is passed as a variable. Next, we add a REST request. We launch the node. We received a correct response, error code 200. We got a server response in JSON format. To pass this string into a table, we use another component from the starter kit, JSON Parser JS. We insert the necessary parameters. We can observe the parsing results. Since we only need the euro exchange rate, we filter it using the row filter component. To display the specified date and rate, let's return to the Table into Variables node. We need to convert the variable back into a table. Join columns using column union. The component is ready. Let's view the result of the submodel's execution. This way we can get the exchange rate for the date that is first on the list. To get the rate for all dates, we use a loop. Go into the settings and link the loop to our submodel. Connect the input port with the list of dates. In the loop settings, we select loop type, group processing. Type of batch processing will be grouping by the unique values field. We also activate the parallel processing parameter. Launch the loop. We executed 382 GET requests in just 15 seconds. We perform a left join for two tables to calculate the price in euros. Use a calculator to divide the price by the exchange rate. We have obtained a new field with the price in euros for each product. Note that the exchange rate depends on the date of the product sale. We wrap these actions in a submodel and give it a name. Export this table to the SQLite database. The database already exists, so we go again to the Connections item and specify our connection. Export the database to the desired table using Export to Database. This workflow will be available via a link. REST requests may not work, as the API key may be blocked.